Hello again, welcome back to Thinking Maths. Again, my name is Jeff and we're continuing our series on exponent laws. Now the first video I have in this series was the multiplication law, which you can see here on the board. And I left this here because it really relates closely to the next law we'll look at, the division law. And the division law states this: a to the m divided by a to the n equals a to the m minus n. Now, thinking principle number 1 says concepts in math repeat themselves. Now in this example, we see that we multiply, we add. Now, division is the inverse operation of multiplication, and subtraction is the inverse operation of addition. And you'll see that several times as you grow throughout math in your high school or in beyond days. Lots of times with what you do with multiplication, you'll do the opposite with division, and this is a perfect example of that here. Instead of multiplying and adding, we're dividing and subtracting. Again, I'm using a to the m and a to the n. A base of a suggests both of these numbers, when substituted, must be the same. My base remains the same, and I just subtract the exponents. Again, let's take a look at a few examples to show what this looks like. Okay, we'll start off with a really quick example here. P to the 6 over p squared. Again, I'm dividing. Yes, I wrote it as a fraction, but fractions and divisions imply the same thing. Same basis, so I just subtract my exponents to get p to the power of 4. Again, using fractions, I could have q to the 1/2 divided by q to the 1/4. Okay? And with that, again, according to my law, I just have to subtract my exponents. Now, 1/2 minus 1/4, again, you can't subtract fractions unless they have a common denominator. So I'm going to times the top and bottom by 2. I get q to the 2/4 minus 1/4, also leaves me as q to the 1/4. Now for this last example, like a textbook, I'm going to throw a wrench in the plans. I'm going to have y to the 4/5 divided by y to the 0.75. I'm going to make it a negative as well, just because I can. Now, thinking principle number, number 2. Math can often be broken down into simpler terms. When I see students come across a complex problem that changes things, and in this case we have fractions and negatives and decimals, they start getting lost and panic in the different numbers, and they think, oh, this is nothing like I've covered so far in this section. I'm here to say, well, no, we just have to break this down into something that's more user-friendly. Okay? So what I would do, I would either convert the fractions to decimals or decimals to fractions, so I'm working in the same thing. And in this case, I know 0.75 is 75 cents, and if I had North American currency, I would say, well, that's 3/4 if I was making it with as few coins as I can. So I'm going to convert 0.75 into 3/4, and again, I'm going to apply my law, same basis. I'm going to subtract the negative 3/4. Now what's important that you don't forget this negative here, because our principle says we have to subtract whatever number this is. In this case, n was negative 0.75, so I have to put that in to that situation there. Now I have two negatives side by side, and again, if you know your integers at this point, you will see that you have to add together when you have two negatives. And again, in this case, to add fractions, I need a common denominator. The lowest one is 20. So I'm going to times this one by 4 and times this one by 5. And I get y equals 16/20 plus 15/20. And depending on what your teacher wants, you can convert that into 31/20 or 1 11/20. Doesn't matter. I'm just going to leave it as 31/20. But again, we took a complex problem. We made it into a simpler one by creating like terms. We applied our laws, and we just worked our way step by step through the problems. Okay? That's the division law. Stay tuned for more laws on the exponents.